Okay, so for today, I am just doing 4.3 day 1, but I'm going to start here with the top 10 functions. I told people that today I would explain how to do the log one. To get the log one, you have to be able to get e to the x first, because they're completely related to each other. All right, so what if I put in a -2? Then that means e to the -2. You don't have to write that there, but that's what we're finding, because you're putting it right there. All right, so what's e to the -2?
9.
It's 1 over e squared. Did you know that? E to a -2 is like 1 over e squared. In case you forgot, the negative in the exponent means 1 over. And then that's about, 3 squared is about 9. Technically, it's less than 9. Okay, so let's say it's about, I think it would round to 1/8. I know it's 1 over 7 point something, but it would round to about 1/8. So then where's that on the graph? Well, -2, 1/8. This is on the top 10 graphs, which are due tomorrow. -2, 1/8 would be like about there. Now, how about -1? Well, that's e to the -1. Would you agree that's 1 over e? That's what -1 power means. 1 over e. And what's that? It's about 1/3. I'm rounding, because 2.7 is about 3, right? So, -1, 1/3. It's a little higher than it was. And that makes sense when you see the big picture that this is exponential growth, and it's supposed to be growing. If I put in a 0, that's e to the 0. What's anything to the 0? 1. So then that's 0, 1. Look at that. It's growing even more. Now let's put in a 1. That's e to the 1, which is 2.718. You might as well be accurate on this one. A little more accurate than 1, 3. So 1, 2.718. Actually, it should be even higher than that. It's pretty steep growth. So now if I were to draw a line through these, I'm going to use red. This is exponential growth. Do you get how that is the e to the x function? Most of you only look at exponential growth once it gets past this spot. The tail end part might be a little weird for you, but if you we just showed you how you put the numbers into the function, that's what you would get. All right. Now, I want to just talk about logs and say, I'm not going to try to reteach you logs right now, too much. It would take me literally a whole day just to get you refreshed on everything you learned about logs last year, so I can't do that. But I can tell you this. You guys know that inverses are exactly a reflection across this line, right? Well, logs are the inverse of exponentials. So, when I ask you on the last top 10 graph to graph y equals ln, that's the same as log base e. Log natural means log base e of x. That looks like this. We've already had a test question on taking a graph, reflecting it across that line, the line y equals x. If this is e to the x, then this is ln x. They are inverses. Do you get if you have a 0.01 like this, that it turns into 1, 0? Does that make sense to you? X and y switch around. That's what inverses do. So every point that we just figured out here on this graph needs to be reversed and made for the other xy chart for ln x. Log base e of x. I want you to write log base e instead of ln because that's what it is. ln is shortcut for log base e of x. So if I had the point 0, 1 right here, then I now have the point 1, 0. Now I'll try to show you why that is. If I put a 1 right here, log base anything of 1 is 0. And you probably forgot that about logs. I totally believe you forgot that about logs. But at least you can trust that if 0, 1 was on this graph, then 1, 0 would be on that graph. Do you get we're just going to reverse them all? Okay, cool. So just take every one of the points that we had, like this one, negative 1 comma 1/3, and put in 1/3 comma negative 1. Every one of the points just gets reversed. Negative 2 comma 1/8, that was approximate. Then 1/8 negative 2. And just keep flipping them around, and you'll have your list of all your points. And it will generally look like this one I'm redrawing over in red here. It'll generally look like that, because it's a reflection across that line, because they are inverse. Tomorrow you get to learn something not inverse, it's called reciprocal. All right, Nico, are you already done with your top 10?
Yeah.
Excellent, that's a good reason to be in the situation that you are. So now I need your attention though for the new stuff. You ready? Ready? Here's the new stuff. We're going to teach you this and this. Now, please stop working on the top 10 functions. That's due by tomorrow morning at 8, and now you know. Okay, so some of you are already done. That's awesome. For the rest of you, get it done. But here's the new lesson for today. It's absolute valuing functions either on the outside of them or on the inside of them. All right, and I want to teach this my way. I'm not going to use the slides. We'll use the slides to review when I'm done. Okay, you ready? Does that sort of look like a cap? And like a baseball cap sideways. Okay? Sketch that for yourself. That's going to be our parent graph. I'm doing it on purpose because you don't know this one. You don't have to know what the functions are. We're going to call this f of x. And you're just going to trust that that's the function. You don't know what the equation is for it. You don't need to know. It's fine. It's just a given function. Now, what I'm going to do is I'm going to absolute value f of x in two different ways. I can either go around the outside like this, or I'm going to absolute value on the inside of the function. But to really understand that, I have to go through just some basics for you. Okay? First off, things you have to understand before you can get this. Do you get that f of x is the exact same thing as y? If I say f of x, do you get that means y? You get that? If I gave you a point 2 comma 6, which is the x part to 2, and which is the f of x part? So did you get all that time we were giving you x comma f of x? Did you ever even think of that before? Some of you have. That's x comma f of x. Every single point you've ever had is x comma f of x. All right. It's like an input and then f of that input. You did, the function got that input put in it, and then it came out with an f of x. Okay. The next little thing you have to understand is absolute value. If you don't get what an absolute value is, then how can I teach you how to absolute value a function? When I absolute value something, do you get if the thing started as negative, that it will switch? Okay, and if it was absolute value negative 5 is 5, but if I absolute value something that was positive in the first place, does it change it at all? No. Do you get sometimes if you absolute value a function, nothing happens because it didn't have any negative numbers in it? Does that make sense? Okay, so there's some functions when you absolute value them, they don't care because they would have been positive anyways. All right, let's talk about that for a second. Some base of those top 10 functions, you're supposed to now know automatically that that looks like that. You would have known that, right? If I absolute value that function and I make all of its y values come out positive, is anything going to change?
No.
The y values, if all the y values have to be positive, do you get, except for 0. I mean, 0 can be 0. It just can't be negative. How about that? Because absolute values can be 0, but they can't be negative. So do you get if I absolute value this, nothing will change? See what I mean? Because they all came out positive anyways. I saw that. That's why you hold your hands up. How dare you? Take your headphones off. All right, so anyways, you're busted. Now I know this for the rest of time. People with long hair think they can get away with headphones. I bet you usually do, too.
I do.
Okay. All right, anyways, back to this. The principal actually said we have permission to ask to see your ears. Is that weird? Yeah, okay. All right, so anyway, back to if I absolute value this on the inside around just the x, do you get that? Also won't matter. If I put in a negative number and I absolute value just the x, notice the difference. I'm going to erase the outside ones. If I absolute value just the x's inside, not squared yet, and then I square it, it still won't matter, will it? If I put in a negative 2, it wouldn't have mattered either way. So absolute valuing this one on the inside or the outside, it doesn't even change. So sometimes functions don't change when you absolute value them. All right, but a lot of functions will change. Here's one that will change. X squared minus 3. Would you please sketch? Would you agree that that generally is your parabola shifted down 3? Does that make sense?
Yeah.
Okay, now, do you get there are some negative y values? If I absolute value those negative y values, they will have to move because they can't be negative anymore. So if I absolute value this thing like this, around the outside, I'm going to use a different color. If I go like that, I just took all my y values and I forced them to become positive. Whatever they were, now they're going to have to be positive. The ones up here, they were positive already, so they just yawn and proceed like normal. Doesn't matter. But these had negative y values down here, and all these had negative y values. So what happens? Can you picture it? They become positive. And your new final answer is all of the green here. Some of it was the original function, never changed. Some of it took the stuff that was underneath and flipped it up because those y values had to become positive now. They used to be like, let's say there. Let's say that was the point, I don't know, 4, 2, I'm putting in a 2 just to see what happened. 2 squared is 4, 4 minus 1 is 3. No, that would be up here. Okay, so then let's say 3. 3 would be 0. Let's say 1. Okay, 1 squared is 1, 1 minus 3 is negative 2. So 1, negative 2. Right there, 1 comma negative 2. Do you get it had a y value that was negative? And do you get when I absolute value that, it's going to become 1 comma positive 2. See, that's why it's right there now. See, that flipped up there because this will become 1 comma regular 2. I'm not going to do this all on every function. I'm just trying to show you this on the first one. You just take anything that had negatives and flip it up. So now, do you get how to do the baseball cap? If that's f of x, what if I do absolute value like this? Do you get that all of the y values? F of x is y, right? I just absolute valued all the y values. Who in here is smart enough to know that it was going to do that? Raise your hand if you had that one right. Okay, maybe I'm going too fast. Nope, I guess not. Okay, cool. See, do you get how that has a lot of points that never changed? Never changed, never changed, never changed, never changed, never changed because they were all positive y values, but the ones that were negative had to change. All right, now this next part is going to blow a lot of minds. Make the baseball cap again. Same exact baseball cap. Label it f of x, but this time we're going to do f of the absolute value of x like that. What does that mean? That means all the x's that were negative have to change. Would you agree with that? Because I absolute valued the x part now, not the y part. Do you note that these are areas over here that had x values that were negative? They all have to change. So I'm going to erase them. Now this is the part where I can give it to you the easy way. and not have you understand what's going on. And some of you, this is the most you're going to be able to do. You're going to get what I'd say right now. But some of you will be able to catch on to why. Okay, that's the harder part. So for right now, here's what happens. Now the question is, why does it happen? That's the hard part. Here's what happens. The answer is the red part, which never changed, and the blue part. Now, it took me as the math teacher a while to understand why this happens, but I think I can explain it to you, and I think many of you, but not all, will get it. I mean, you won't have to get it. You won't have to explain this on this test, but if you want to understand, like, why would that happen, see if you can hang with this. That spot, let's call it 0, 3. When I absolute value either the 0 or the 3, it wouldn't even matter. It wouldn't change, would it? That's why that point doesn't change. Let's say this point right here is at about 2.5, comma, it's a little less than 3, 2.5 maybe. 2.5, comma, 2.5. If I absolute value that, it won't change either, will it? You might be like, why are you doing this? These points aren't going to change. You're right, they aren't, but let me show you more. I'd say this is at about 4, 0. Let's say this is at 5, -1. You'll understand why I'm doing this in a second. 5, -1. And let's say this is at about 9, -1. Okay, so let's say I go over here and I'm about to feed this a -1. Input of -1. Do you get the -1 would drop in here, and the first thing that would happen to the -1, it was to change it to +1, because they're absolute valuing it. Know what I mean? So that -1 just turned into +1. So the function will act exactly the same as if I put in f of regular 1. And we know what that is. It's right here. It acts just like I put in regular 1. And so it's going to repeat that over here. I'm going to say that that point right there was at 1, 2.8. It was really close to 3. So 1, 2.8 turns into -1. Why would you have a -1? Because when I put in a -1, I did put in -1. It acted like I put in +1, and it gave the same output of 2.8. I'll give you a maybe even easier answer. Let's say I put in a -4. Isn't going to act exactly the same as if I had put in a regular 4. And what is it programmed to do when you put in a regular 4? Give you 0, and therefore it'll give you the point -4, 0. So some of you maybe understand why it's reflecting that over, because whenever you put in a negative number, it thinks you put in the positive number and gives you f of that. All right, and if you didn't get all of that, and you can just make them have y-axis symmetry, take the right side, flip it over to the left. That's all you got to do. But if you want to understand it, I tried to explain it. Okay. So that is much more complicated than the other kind. But the graphs are really clean and easy to look at when you're done. They have y-axis symmetry. So you erase the left side and then copy over whatever's on the right, reflect it across. Let's see if you really got that. Now make a mountain with its peak slightly to the left of the y-axis. There's your function. There's your f of x. If that's f of x, if you really understand this, f of x with the bars around the outside should be pretty easy. Go ahead and do that. Show me what you think the graph looks like when I absolute value around the outside of it. Well, Mr. Server, all the negative values here just flip up like this, and I'm going to redraw over it in green, and there you go. Raise your hand if you had that one right. Okay, cool. Then the more complicated one. I'm going to go over here. It's the same exact picture. You stay organized any way you want. I'm going to just do the same picture, f of x, and then I'm going to go f of absolute value of x on the inside like that. Okay. Do you get that the negative x's are what is impacted. They're the ones that get affected by this. All right, then sketch this as best you can. Pause for a second, and you give it a shot. Okay, so all your negative x's need to go away, so there they go. And if you're at super basic level understanding, you're just going to go, okay, well, he told me to make it have symmetry, so there we go. And if you understand it, you might be like, well, yeah, when you put in a negative number like negative 4, it acts like you put in regular 4, and then it just copies that number over, and yay, I get it. Okay, raise your hand if you had it right either way. Okay, good. Now, that's pretty much it, except sometimes they give you a actual function. What if they said x squared minus 7? Visualize it first. Don't even draw it, just picture. What would that look like? The shape is called something that starts with a P. What is it? Parabola. Shifted where? Down 7. Now, picture that one. If I absolute value it around the outside like this, would you agree that takes anything that was y values that were negative? See, it's like I did this. See, I went around the whole thing. All the y values that were negative have to become positive. If you know what it looked like, you know it looked like this. There were negative y values, weren't there? In here, these were all negative y values. Why would that happen? Because you were subtracting 7. So what if you put in 0? Wouldn't you get negative 7? So you would have had a negative y value, but now it won't have a negative y value, so it would look like that. Does that make sense to you? Okay. Okay. Then here's the ultimate challenge. I'm not giving you the picture, but I'm going to show you what it should look like. Graph that first, and then I'm going to put an absolute value in a certain spot. And then you're going to say, oh, well, then I'll change it to this. Are you starting with a parabola and moving it somewhere? Sylvia, tell me one direction it should move.
Down.
Down, how many?
2.
False.
Oh,
okay.
Oh, sorry.
Down 5. And then what is that 2 then actually? Right 2. You are correct. So it's right 2 and down 5. And so generally speaking, it's kind of like that-ish. Now, if I needed exact points, could I get them? Don't forget, XY chart, best friend in graphing. We're not going to make a bunch of points here, but you could. So if I wanted this to be super exact, that's what I'd do. I'd just get a bunch of points. I'd put in 0. The easiest one would be put in 2. Because then it's 0 squared is 0 minus 5. 2 negative 5 would be one of the points. All right. And that happens to be the vertex of it. Then when I absolute value this puppy around the outside of it, will it change? Yeah. Pretty quickly you can go, oh yeah, just this part pops up. There we go. Who had that one right? Cool. What if I absolute value the inside and the outside? Can you do that? Yes, you can.
Wait, what do you mean the inside?
Absolute values in here also.
So weird.
Interesting. It doesn't change anything, he says.
Well, until you absolutely on the outside.
Well, yeah.
The inside doesn't.
Okay. So if I had just started with absolute valuing the inside, wouldn't you have thought that this thing has to reflect across? All right, let's look at that one. So everybody make one more. We'll just sketch it. Just draw it like this. Like that. Okay, parabola shifted to the left and down, and there it is. Good. Okay, so what if I say that's f of x, and what if I say I'm absolute valuing the inside? I want to go f of the absolute value of x. Would it change it?
Yeah.
It would change this one. It'd be slight, but it would change it. Because it would look like that. Because the whole left side needs to be erased. And then it has to have symmetry. It's tricky, isn't it? Trickier than you'd think. You'd think that this thing wouldn't change, but since it was off center, do you get if it would have just been a normal parabola shifted exactly down, then when you flipped it, it wouldn't have changed? But it was the fact that it was shifted to the left that changed it. All right. Okay, so taught you how to do ln of x by basically taking e to the x and reversing all the numbers on the table because they're inverses. Taught you how to do absolute value on the inside or the outside of a function. Last thing is just introducing this. I'm not going to try to teach you this today because it's really complicated, and frankly, I think your brain's full at this point. If I try to teach you this, I think we're just going to mess up what I just taught you. You're going to get it all confused and mixed up. So we'll wait till tomorrow. But that is not inverse. Can anybody tell me what it's called? Reciprocal. We're going to teach you how to do a reciprocal of a function, and it is really weird. But we're not going to talk about it today other than just introduce the concept that there is a reciprocal. And then I'm going to teach you that tomorrow. All right, so now we're going to go through the slides as just a review. Do you remember that sometimes we'd give you a point and say, do all of these changes? Pro tip for you, that 9 messes people up big time. Would you agree that that is a 9 that is being added to the function? It is a positive 9. Couldn't you put it back there and combine it with the 7? Yes, you could. And you should, because it'll make your life better. And what is 9 and 7? 16. All right. Now, let's see if you remember this. The 6 has to change to some new point, and it's, like we got to figure out what this is. So 6 is going to change. Which part changes the 6? The inside or the outside? Inside. So the easy way to do this, the hard way is to think of everything that was done to it and do it in the opposite order and the opposite thing. And that's really complicated. So we gave you a nice, easy way. You go like this. Everybody solve this. 3 parentheses, 2 minus 4x equals 6. Solve. That's the easy way. Try that. Compare with the kid next to you when you get the answer, but don't just yell it to them. Maybe they're not done. Ask them if they're done, and then compare answers. I'll pause for a second. And then hopefully you remember how to do the y stuff. You trust the y stuff. So just the stuff on the outside does the y. And then you'll know what your new point is. So take a second, find out the x, and then find out the y and make it into a point. Now some kids will have distributed this. I'm just getting rid of it by dividing by -3 on both sides. And it's okay, you get the same answer at the end because distributing works, right? But you don't have to do the distributive first. I think this is a little faster. Now I'm going to add 2 to both sides. And I get -4x equals 0. X equals 0 over anything is 0. There we go. Did you have 0? Raise your hand if you had 0. Oh, okay. Hold on. Oh, I subtract 2 from both sides. Thank you. Subtracting 2 from both sides. Oh, my goodness. My bad. Sorry. -2. I just saw that minus, and I really thought it was a -2. I was saying kids do that all the time. There, I did it too. Okay, so that was a +2. All right, so now -4x equals -4x equals 1. Raise your hand if you had 1. Yay. Feel bad for the other people who made the same mistake as me and raised their hand before when I said it's 0. It happens. All right, now the y part. I'm going to multiply everything by -5. So the y part was -2 times -5 is 10 plus 16. 26. Raise your hand if you had 26 on that one. Okay, cool.
Wait, what?
Okay.
At 16.
Aren't we taking...
Oh.
Yeah, this was an add 16 because remember the whole, like, there was a plus 9 and there was a plus 7 and that made plus 16?
I forgot to change it to.
Ah, it happens. Hey, I made a mistake. You can make one too. I think it's right though, isn't it?
Yeah.
Okay, good. All right. Okay. So there's a blast from the past. Stuff you have to know. Moving on. We're not doing this. Yay. It'll save us a bunch of time. This. I want to show it to you in this context. First of all, y equals x. Everybody just graph that. Y equals x. By now, we've talked about it so much from that inverse thing that you should have known it was that, right? Right? Okay. Then, what if I absolute value it? Never thought of it that way before, did you? If I absolute value around the outside of it, then everything that was negative has to pop up and become positive, and see why the absolute value graph looks like it does? Huh? Okay. That makes sense to you? The stuff that was negative popped up because I absolute valued the x, and that's why absolute value of x looks like it does. If you don't feel like that's right, well, graph it on your calculator. Why? Because absolute value of x looks like that. And one last poke about this. What if I had x squared and then I took the square root of it? Some of you think that, well, that's just the same as x. What is it?
Absolute value.
If you graphed this, you know what would happen? It would look like this. And that's why when I'm solving this, I don't like it when you go square root, it's just x. No, it's not. It's not just x, it's the absolute value of x. Because it is. Because if you do this on a calculator, you get this. And you know what that looks like. It's a V shape. We just talked about it. And the square root of 16 is just one thing. Otherwise, your calculator would have to say it's two answers, 4 and negative 4. But it's not. And then you can split it into two things because of the absolute value. Just trying to make sure you understand it. All right. Then moving on to this page. I don't think it's smart to be mixing in piecewise functions with this unit. So would you just sketch what x squared minus 4 looks like? That should take you like 5 seconds. Sketch that. We're almost done here and I need to go fast. So parabola moved on forward. Boom. Done. What if I absolute value that? Around the outside, that's the y values. That's like doing this. So then the y values flip up. Boing, like that. Does that make sense to you? Did the domain change? Nope. Did the range change? Yes, this one's range is from 0 to infinity. And it can be 0 because the absolute values can be 0. This range went down to negative 4 to infinity. Okay. Hang on. Is this equal to that? It's a trick question. Need more information because it depends on what? It depends on the function. Would you agree that this function right there, when I absolute value it around the outside, absolutely nothing would happen? And when I absolute value it on the inside, then that whole left side disappears and you flip it over and nothing happens. Do you get in that moment? They are equal. So it depends on the function. If the function doesn't change at all, well then sure. So it kind of depends. All right. Not going to do that one. This, I hope you'd get that it was flipped over. We haven't done many of those. Flipped over and then moved up 3, so it would look kind of like that. Once you get that starting picture, wouldn't it be pretty easy to absolute value around the outside? Then that would make the y values that were negative flip up. And absolute value on the inside. And that would not do anything, because look at it. If I reflect this over there, it's right on top of itself. It's going to be in the same place it was. All right. And that's all. So let's get the homework and look at it together. I'm going to recommend that you only do this page because there's a Schoology quiz tonight. It's only super easy. in my opinion, super easy Schoology quiz, but it does have 10 questions. So we're cutting the assignment down by saying, do one of these really well, and because I like you guys, I'm going to help you move this 4 and put a +4 at the end. Because you remember how I screwed that up? You might screw it up too. If we don't move it to the end, and then you won't screw it up. Do you get this as an upside down parabola that's been moved? Oh, and which way has it been moved besides being upside down?
Oh, it's to right 2.
Right 2
Up 4.
and up 4. So if I go right 2 and up 4, I can put a dot right there, and look at that. It's an upside down parabola. That's generally what it looks like. Okay, and then they're asking you to do some changes. Absolute value around the outside. We've practiced this. Absolute value around the inside. You know, that's like absolute valuing in there, see? Around the x. So that's the kind where the left side is erased and then you flip it over. You might want to be a little more careful on your graph. I just totally sketched it there. You can get more accurate points. Because the XY graph, or XY chart is your best friend in graphing. So your assignment is just that one page. Skip the other 2 pages. And then let's open the Schoology quiz before you forget, but a question first, yes?
Okay, so if I have the function y equals x minus 2 squared, it doesn't change anything if I absolute value the x minus
Wait.
2?
Y equals x minus 2 squared. Is the squared like this?
Yes.
Okay, then that is a parabola that has been shifted right 2. Now you tell me, if I do the absolute value around the outside, then nothing would happen. But if I absolute value on the inside, something would happen. And I know it's confusing, but think about it. If I put in and I get a, here, you got to go, don't you? Okay, thank you. If I put in a -1, let's track what would happen.
Okay.
If I put in a -1, -1 minus 2 makes -3, and -3 squared makes 9. So in the old XY chart, when I put in a -1, I'm going to get 9. Would you agree with that?
Yes.
All right. If this hadn't even had absolute values, if the absolute values hadn't even been there, wouldn't it have come out exactly the same?
Yes.
All right. So if I put in a -1 here, or sorry, a regular 1, let's put in a regular 1 and see what we get. A regular 1 goes in, and 1 minus 2 is -1, and we absolute value it, and it becomes 1. And then you square it is 1, right? Okay, so over 1 up 1. Okay, so why should this thing look like this? When I put in a -1, or when I put in a +1, I got 1. When I put in a -1, I should get the same thing. Because, like I said, the first thing it does is absolute values it. I put the absolute value bars in the wrong spot. That's the problem. I put the absolute value bars in the wrong spot. Think about where should I have put the absolute value bars?
Around the x.
Just around the x. Now that explains why. Because when I put in my -1, it would change it right away to a 1. And at least I talked my way through it. I figured out what I was doing wrong. When I put in the -1, it should instantly change it to +1 and then subtract 2, which makes it -1 squared, which would be 1. So when I put in -1, it acts the exact same way as when I put in +1, and that's why. And I had the bars in the wrong spot. It's my bad. It should have been just around the x. Yep, that's where the bars should go. Okay, thanks for talking that through with me. It is confusing, no doubt. I mean, this a mix of like, if I just show you the pictures, it's not that hard. But when we really dig into the functions, it can be confusing. All right, so you have this one page. That's it. Good Lord, it has never been an easier on paper assignment, but you have the Schoology quiz too. Just to make sure you found it, and Schoology was acting weird earlier today, would you please just open the Schoology quiz? It's not timed. Just open it so that I know that you found it. Yes, it's resumable. And that's all I have for the video for today.